Okay, so hello everybody and welcome to our webcast today on why and how to get started with IoT data connectivity. My name is Derek Komanek. I'm a Senior Consulting Manager here at Matrikon, Honeywell. So the idea today is to go over not only what, I guess briefly, what IIoT is about and also some of the benefits that are quickly emerging, let's say, in the marketplace based on that shift in technology, but also how you can start to take advantage of it, or at least how to prepare your business to engage with the technology, given that you already have, of course, a lot of existing infrastructure. So to get started, there we go. So to get started, quick introductory slide. Of course, the topic is big. There's all sorts of projections flying around. I've been watching them, as they sort of go up and down throughout the year. But one thing is clear is that in overall in IoT, the Internet of Things in general, there's huge expectation for just how many devices will be connected. Of course, the security around that, how much revenue that will generate, both on the, let's say, the consumer side and also on the industrial side, in manufacturing sectors. So looking at things like, what Accenture took a look at, they did a study with, say, 20 different nations, and looking over time, as you project into 2030, I mean, they're expecting truly astronomical numbers to start showing up on how businesses are affected. But more so than the let's say projections of analysts and enthusiastic companies looking at entering the market, it's also apparent that from a national level, so basically on a country level, this is also something that's been noticed, and just the overall digital economy, or adopting those technologies to allow businesses basically globally to compete, that's also shown up on the radar, let's say, in the political arena. So clearly the trend is strong. And now the question is, so how does that affect us? Or how does it affect you? So when we talk about digital business transformation, businesses, of course, are, especially in the industrial side, obviously there's a part that's doing the R&D and the manufacturing and the production, and then there's another side to the business that actually has to engage its customers. So really, businesses are faced with sort of two challenges, one being to bring the technology and into its own operations, and both from a business side and from the production side, but also to find new ways to engage its own customers for each business. So basically, we've got the IoT. That's a lot of that is happening in the commercial aspect side, and how, again, you interface with customers. But that also feeds back into what you're doing in the production side. And overall, when we talk about digital business transformation, it's actually bringing those two together. So in this presentation, I'm going to focus on the industrial side of things, so the IIoT, which basically looks at how you work internally with your systems, and how you bring things forward, or how do you introduce new technologies into your operations. So if we sort of take a step back, the question always is, so what are the drivers, right? What are the business drivers on the industrial side for engaging in this IIoT? I mean, currently a lot of businesses, especially in the, let's say, the process side, have a lot of systems already interconnected. There's a lot of historians. There's a lot of these systems already supposedly in place. So what's new? Well, there's a number of reasons why things are different. Three key drivers, let's say, that we look at, or I'll touch on here, are improving production efficiency, working on process reliability, and working on supply chain optimization. Now, by being able to combine or access data more freely and deeper into the actual shop floor, or at each location, into the equipment, which previously may have been either too expensive or just too difficult to connect to get data from those systems. As that continues to expand, because with the IoT, not only are we going up, as we see in the picture, into the cloud, or basically being able to share data or collaborate on that data, more freely throughout the enterprise, but also it's actually going deeper into the shop floor. So while traditionally a lot of connectivity has been established for working with process data, so basically the information that's required to actually run the facility or the systems, there's also a lot of data that's not being looked at, or whether it was too expensive or just, again, inaccessible, and that would be the diagnostics, right? So as we look at the cost of sensors and smart devices being able to be deployed into production environments where you can start to add that capability, whether it's from a third party to access the diagnostics information or just to be able to communicate to the device that already collects it anyways, all of those sort of roll up into the concepts that are common to IIoT. Now, of course, a lot of these things are premised on top of cybersecurity, so I put that in red there. So basically, you know, the key thing in all of this is ensuring that, of course, the proper measures are taken to secure the data. So even though in the pictures we show clouds and it looks like it's just you're talking to the general intranet, of course, that is not the case. You can talk to servers that are in the general cloud or on internet, but a lot of times also you will have on-prem type facilities or basically private clouds as well. So I'm not going to dwell on where the cloud is in this presentation. The idea is once you start finding secure ways of accessing the information from the lowest levels in your organizations, in your plant or your manufacturing facility, then the question is, where does it go? That just depends on where you're hosting your data or what your setup is. But how you establish the communications and ensure that they're secure, that's something that I will cover here. So looking a little closer at, where do you go from here, from the kind of a top-level view of, there's a lot of improvement that you can make. I thought we'd look at each one in turn. So when we talk about process reliability, some of the business cases for those are improving your ability to monitor your assets. So basically, again, keeping, let's say, just aware or tabs on what's actually happening with the assets. At the same time, predictive maintenance becomes possible. So as the more diagnostic information and up-to-date status that you have and visibility into the systems on the shop floor, the more you're aware currently what is happening, and therefore if you're also collecting this information and performing analysis on it, that also allows you to start to actually predict, of course, when, for example, a failure might occur, which then helps you to avert unplanned downtimes and such, right? So you're not only that not only prevents shutdowns, but it also improves when you actually do the maintenance, which also potentially lowers costs significantly because you're not sending people out when you don't need to, but you do send them out when you actually do need to, right? And also expert guidance, and that basically speaks to the ability to collaborate. So once you have the ability to access enough information on the shop floor, whether you're creating centers of excellence where experts can remotely assist with certain technical issues on the shop floor, either it's on location or remotely, that of course also helps you run more reliably but also more efficiently. So all of these, although these are high level, or these are sort of at the business level, the drivers of why you do it, all of them actually, of course, sort of boil down to the starting point, which is the ability to actually connect to the assets and get the information reliably and securely. Okay, so when we talk about production efficiency, same thing, whether it's operator effectiveness, and again, that's how and what type of information you're getting to the operators, where can they get the info, how in depth can they go, how much context do they get from that information, how difficult is it to set that up, that sort of plays into that. Maximizing quality, so ensuring that products aren't off spec, optimizing the process, so basically using feedback and looking at, when we start talking about feeding data, let's say, for example, into the cloud and starting to identify, to correlate incidents where something goes off spec, and to start to understand, what in the process, for example, may be causing certain risks to be higher than expected or than the norm would dictate. All of those, again, rely on the ability to access information from the lower levels. And then work with them, say, in the cloud where you start to do more of the analytics, or in between when you're starting to do the processing on what we call fog computing, or basically on the edge, where you're starting to also crunch the data, make it available potentially to the operators at that level, and then also feed it into the cloud. And then as we look even further out, we talk about supply chain optimization, so whether that's planning and scheduling, or optimizing work in progress, and reducing, for example, when you have to order inventory, or at least focusing on just-in-time deliveries. And then that basically ties into the enterprise supply chain execution as well. So the high-level sort of drivers with the process reliability, production efficiency, and supply chain optimization, they actually have a lot of different aspects, and each one of these actually could be, we could dive into and actually start to pick it apart and say, well, how, when you access the data from the lowest levels, how is that actually, when you draw the line going back up, how does that actually help make, asset surveillance, or maximizing quality, or reducing the WIP? How you implement that is actually dependent on how much data you have and how easily it's accessible. So I guess the key point to this is, if you're wondering why, from a business standpoint, why you would start to talk about, let's say as a mundane thing as just data connectivity, it's because all of these higher level initiatives and the business cases, they actually depend on it. So that's why we sort of start from the beginning. Now, if we look at the infrastructure that you need, I definitely don't want to paint a picture that if you just can connect to a bunch of devices or throw more tech at the shop floor and have better visibility to sensors, that suddenly all those great things are going to happen. So, especially being part now of Honeywell and having access to some of the other solutions that they or we provide, as far as when you look upwards, even though Matrikon focuses basically exclusively down at the shop floor, and we say this is how you connect, and here's how you can basically feed that data into the cloud, or to make it more accessible between systems. Really, there's a lot more that has to be put into place if you fully, as a company, want to take advantage of what we call digital business transformation. Right? So once you have the data shown at the bottom here, the shop floor visibility, and of course on the premise that it's secure and you're maintaining the context, and you can of course get access to the different devices that you need, then basically you're going to go through a bit of a process or a cycle, right? So you have to be able to capture this information, process it, maybe crunch it down a bit. You don't necessarily want to feed it all into a giant data lake up in the cloud. That can also get expensive. So, people say that storage is cheap, but when you actually look at transferring all the data into the cloud, that has to get sent somehow, somewhere over the network, and whatever cloud platform you're using, that also has its own expenses. So just blindly shooting data into the cloud because one day it'll be useful, that's not a great strategy, right? So whether you reduce that data at the edge, so when we talk about fog computing and you actually sort of crunch it down to make it, change at least some of it into more of usable information, so shifting a bit from data to information, you feed that in, you capture it. You also have to have an asset model. Now, when I'm going to talk about a little bit later on here about OPC UA, which is a standard for connectivity on the shop floor, actually throughout, let's say the round trip for the data, one of the key things to understand is that, all the different devices that you have on your shop floor and the systems, they of course store information in their own formats, their own way. They have different levels of information packed into them. Some of them have basically just a value. Others have a very rich, let's call it metadata, associated with them, so the units and all sorts of parameters on maximums and minimums and such. So even though all those it's extremely important to capture that, you actually need to put it into some kind of cohesive asset model that brings all this together, because in the end, if you want to take advantage of the advanced analytics that are provided either by specialized applications or large analytics engines in the cloud, you actually have to have some way of understanding how the information relates. One piece of information relates to another piece of information so you can draw the conclusions. So in order to do that, whether you put the infrastructure in yourself or you're using sort of a hosted solution, that is something that as a business you have to commit to and to actually embrace to fully get the benefits. And that's what we see in the diagram here as we sort of loop back and we start to come back down through the cycle and we start talking about the production efficiency, the reliability of the process, and the supply chain. All of those actually are dependent on you having done sort of the work in the background. Now, again, companies like Honeywell and others, they provide a lot of that. They have that system worked out. So our focus here is in the webcast is actually looking at the shop floor down below to say, okay, so how do you best prepare your business in order to make that information available, but also to ensure that it's secure and that you, of course, don't wipe out the ROI on your existing infrastructure, which you've got in place and you're not going to tear out just because you're chasing, a more profitable way to work with the data up above. Okay, so just sort of wanted to put that into context, that the data is absolutely important, but you do have to be aware that there has to be a further plan. It's not just a one-step type deal. Okay, so if we were to break this down into sort of key areas that we look at when you're rolling out an overall IoT strategy, you would of course start with data connectivity. So you want the visibility down to shop floor. You want to have the context. So basically, like I said, let's call it the metadata or the parameters that come with the information from each of the devices, as much as each can provide. You want it to be secure and definitely need it to be reliable, especially if you're talking about some real-time applications. Now, at the same time, we don't want to feed, as I mentioned, the data, all of the data up into the cloud. So you also want to have some intelligence sort of at the edge. So sort of anything that sits outside the cloud, but basically you're doing sort of the computing, let's say on premises, or they're local to where you're gathering the information. You also want to do a little bit of data aggregation there, maybe some basic analytics, maybe exercise some local control, because certain things can be done, let's say, automatically. And then the next step is also, of course, moving up into the cloud computing, where now you have a lot of data being brought together. You're consolidating it. You're putting it, again, taking information either that was already put into an architecture from the edge, but the structure, or you're doing that, you're organizing that in the cloud. Then you do advanced analytics, and then, of course, you shift to collaboration and actually doing something with the data, which on the previous slide was sort of the down arrows going through and actually starting to see some benefits out of it. So when we're talking about the overall IoT, there's a lot of efforts, like I said, on it is on national levels, and different parts of the world have sort of had different starting times into it, and have sort of approached the topic in different ways. So if we look at just a few of them, the key ones, the first one that really showed up on the radar was from Germany, and that was the Industry 4.0 movement. So Industry 4.0 is basically, when you're talking about IIoT, Industry 4.0 focuses on discrete manufacturing. And it doesn't just look at connectivity in discrete manufacturing. It's a very comprehensive, actually, document put together. Actually, it's a couple documents that talk about how you make the whole digital economy work. So it looks at everything from how you train the workforce and prepare them for this, because as the environment becomes more intelligent, certain manual tasks are no longer necessarily done by humans, because of course the systems are getting smarter. They sort of take care of that. But at the same time, there's actually a growing need for people on the higher levels, or the sort of the decision making or expertise that has to be applied in order to use these systems. So, training the workforce to take advantage of that, and also how all the various systems work together and how you build an ecosystem of, supply chains and smart manufacturing, the actual manufacturing systems that talk to each other, how products interact with the manufacturing systems as they go through the system, and et cetera. So it's very comprehensive. And that sort of got the, that got the ball rolling, or really sort of focused approach to, let's say, an industrial application of what the IoT has to offer. Now, in the U.S., a really popular consortium is the IIC, or the Industrial Internet Consortium. There's a lot of member companies in there, and they've actually they were a little bit slower out of the starting gate, but they also took a wider approach. So the IIC actually focuses on all industrial applications for the IoT, not just discrete manufacturing. So if you were to kind of look at it, the IIC covers the entire topic of industrial with the IIoT, and Industry 4.0 is more like a horizontal slice, which focuses specifically on the discrete manufacturing. And then in China also, they've now started, a little bit later after that, they've started their own sort of initiative called Internet Plus, or Made in China 2025. But basically they're using, again, a lot of the concepts that came from the Industry 4.0 and IIC initiatives. So those are the sort of the main drivers. And what's happened is, when we attend a lot of the largest shows in Europe, for example, they're being held in Germany, and on manufacturing and communication technology. One thing that's happened is the German government, as it came up with this plan for this Industry 4.0, it also wanted to find sort of a unifying, maybe not protocol, but standard, which would help tie everything together. As you know, in industry, we have a lot of different verticals. So when you're dealing with facility management or building automation systems, that's different than when you're dealing with actual production systems, which is different, again, than other systems that are used for transportation. And the question is, how do you share or bring all that data together? Because again, this is meant to increase the collaboration. So they went and they actually did a lot of independent analysis of the entire spectrum of the standards that are currently available in the market for doing all sorts of communications. And some of their criteria were, number one, how flexible is the technology for actually describing some of the relationships that are required? Because a lot of these systems, they are not just simple mappings of, here's the temperature and here's the unit and here's the min and max parameter. It actually describes the behavior of a device within a much broader system. Sometimes there's state-based descriptions. So it's definitely a more complex requirement as far as how you maintain context between different silos of industry as you share data between them. That was one requirement. Another key one absolutely was the security. So as things scale up, does the standard enforce security, not just on paper, but when you implement it, does it actually hold water? So they actually did a lot of testing of protocols to say, and standards to say, which one would be the one that could kind of tie the different systems together. So not that all the other systems with the standards would disappear, but they wanted to rally behind one to say this is sort of the main one that we're endorsing as far as, if you're trying to tie different systems together, what you would use. So having said all that, when they went through their analysis, basically when they came back, what they found was that the only one that they could find that was able to handle all these types of requirements, whether it's the scalability, the security, or the performance, or the context, was actually OPC UA. Okay, so I'm assuming most people have heard about OPC UA, but if you haven't, that's okay. I've got a few slides that I added in just to give you an overview of what that refers to. But the important part here is that, the government didn't want, the German government, what they were looking at is they didn't want to have multiple standards that were the official ones for Industry 4.0, because again, then that creates barriers as to which vendor supports which standard, and again, can they communicate or not? So on the plant floor, or as you're talking into the enterprise as well. So they chose OPC UA, so that's how come that OPC UA obviously got a much welcome boost. So there's a lot of activity going on in Europe with OPC UA, and that has crossed over into North America as well, and we're seeing a sharp increase in attention and from both vendors and end users as far as the demand, let's say, for OPC UA. Okay, so let's talk about OPC UA a little bit. I'll make this relatively brief. So OPC UA is run by the OPC Foundation, so no one company actually, of course, owns the standard. It's run by the OPC Foundation. It's prominent, highly prominent in oil and gas applications. It's also increasingly now found in building automation. Utilities use it a lot. We have pharmaceutical applications. Discrete manufacturing uses it a lot as well. It's gone through two major, let's say, generations. We're on the second one now. So initially, the first generation of OPC was called Classic OPC. It had, it was an early attempt at open connectivity. It ran on Windows. It had its, various security limitations because it depended on Windows to provide that. And, when you mix an IT system with something that runs in OT, that doesn't bode well. So it had its growing pains, let's say. But now in the second generation, which has been around now for, I think it's about 6 years, OPC UA has basically, taken all the lessons, good and bad, from generation 1 and completely revamped how it works in the next generation, which is called OPC UA. It stands for Unified Architecture, and it basically brings in all the different types of data. It brings in or adds in modeling, so you can do very complex models to represent the information and even actions that need to be taken on that information. And it sort of brings everything into one standard. It's a large standard, but it's therefore also comprehensive, and it's built from the ground up to be secure. So rather than relying on an operating system to provide this type of security, that it's actually built into the specification itself. So if you're using the UA protocol, it basically offers the encryption and the signing and, let's say, increased resiliency to various types of attacks. It's just baked right into the standard, and therefore the products do that as well. Okay, so that's why we're talking about OPC UA, and that's why the rest of the presentation basically focuses on it, is because this standard not only allows you to transfer data security from systems that are built for OPC UA specifically, but given that it's so flexible, it also allows you to translate between standards. So if you have systems on your shop floor right now which don't stop OPC UA, it actually has the ability to model and capture whatever the formats are for the information that's in those systems, and you can translate them without losing that context into OPC UA, and then working with that data in a consistent manner. And that's actually quite important because, again, when you're bringing these separate systems, whether it's in a particular industrial silo or you're talking about different businesses bringing information together, it's important to be able to actually understand what the context of that data is, or to be able to at least delve into it, let's say for the analytics packages that are working on the data. Okay, so that's in a nutshell sort of what OPC UA does. One final thing, when you see the circle here on the left, there are a lot of standards that are working together with the foundation, because what they found is that even though the various open standards that exist, they are specialized for particular industries or particular applications. So the idea is not to get rid of them. What's important is that the ability to share data between the open standards, that's what OPC UA can provide in this case. So yes, systems can be native OPC UA, or they can support translating data from these other standards. So it sort of ties all of them together, which again is why, of course, when we talk about Industry 4.0, it stood out. Okay, so to give you a very quick overview of, if you're not familiar with the protocol, or what's sort of the difference that OPC UA brings from a true connectivity standpoint. In the past, when we talked about the ability to talk to different systems on the shop floor, what that meant is that they would have typically some kind of protocol built in. Some of them were serial, some of them use Modbus, others use proprietary protocols, but basically you have to somehow connect to your PLCs and actuators and whatever else you're using in order to actually number one, find out what's happening on your shop floor, and number two, to try to do some supervisory control on it. Now, if you wanted to access that in a central place, you'd typically have an HMI or a historian to capture the data, and that would run on a PC that's shown up above and then in the top bar there. Now, the trick was, if you wanted the communication, you have to actually install a driver. So here, for example, for the HMI to talk to PLC1, which is coded in blue, you'd have to install a driver that would talk that particular protocol. Now, if you wanted your HMI to also see what's happening on PLC2, that's another driver you have to install. And if you wanted to see actuator 3, or the actuator, of course, then you had to install yet another driver. And then if you wanted to capture the data, the historian consumes data in a different format than the HMI does, especially if it comes from a different vendor. So again, you are installing more drivers in order so the historian could talk to them. And you can see that that very quickly starts to be a very arduous task, not only for just, say, one PC with only a few devices, but imagine now that you have a lot of different PCs or a lot of different users, and you're installing this all over the place and then trying to maintain it, because of course as the firmware changes or the versions change for the PLCs and these different drivers, you have to maintain all of this. So it was just a very cumbersome way to try to communicate with the shop floor, and you also use resources that communication, or also trying to talk between the PLCs. So when we shift now to OPC UA, what happens is OPC UA can run as a server. So you have a server and a client, and that's not necessarily a PC. We're just saying the application that behaves as a server. So the individual OPC UA servers know how to talk to particular devices. So that's what I'm showing down below on the lowest bar there. You have different types of systems. They have their own ways of talking, so they're native still, nothing changed, right? Whatever's coming from vendors, that's what you're getting when you're buying it. But the point is, if you have an OPC UA server that can talk to a particular device, only that OPC UA server needs to know how to natively talk to that device, because the server then exposes that information in its own, let's say, address space or in its own memory. So when other clients now, all types of applications that come from above, from the top bar, when they're connecting to that server, they now are able to communicate using OPC UA to talk to the server, but they get access to all the information that the server or multiple servers get talking down below. This isolates the top, the clients, from the devices that sit down at the bottom, and therefore you're only updating, if at all, you're updating the UA servers that are sitting sort of in the middle layer there, as opposed to having to install drivers sitting up above. So that, of course, dramatically cuts down on the maintenance and the effort to keep this running. Now, OPC UA, like I said, has come quite a ways since what Classic did. So OPC UA can also run directly on board a device. So it doesn't. OPC UA is independent of the platform, so it can run on small MCUs, so microcontrollers, which are much simpler and cheaper, therefore, than CPUs and sort of the larger PC-based systems. So you can basically have OPC UA now embedded directly into the products, and this is actually what's coming. So when I told you guys that, that phenomenon of people starting to adopt OPC UA or to shift towards it in Europe and North America and actually throughout Asia as well, that's actually happening now. So as Matrikon, since we provide the, let's say, the SDK or the toolkit that vendors use in order to put OPC UA into their devices, we have sort of first-hand knowledge of just how many vendors are actually doing this. And I can tell you, it's a lot of them. So the vendors who are creating the devices are actually putting OPC UA directly on board. So now you can actually start connecting directly to the device, and it will naturally provide that information in the OPC UA format, even though it might still hold the structure or organize the information on board in a way that fits whatever, whatever industry it's serving, or whatever is common for keeping the types of parameters, the types of metadata that's used for a particular application in the particular field. So this allows vendors to basically continue to create devices for their own markets, potentially have those devices used in other markets, because even though they have specialized knowledge and they might have specialized equipment, that now starts to be universal because it can talk OPC UA, and therefore other systems will also be able to talk to them, with the added benefit that now you're getting security directly from the device. So OPC UA is secure from the source or right from the server. So if it's embedded in the device, that means that there's really no gap where you've got, for example, unsecured data traveling off a device to a computer and then getting encrypted and going off into the network. So it actually just makes the system that much more secure. Now, the other thing that's also coming is there's a realization also on the foundation side, OPC Foundation, that people are interested in sending things directly to the cloud. This doesn't apply to every situation. So, for example, in plants where you have complete networks set up with you got your Purdue sort of models where you've got the different DMZs between the major parts, so the control layers and the operational and the business. Naturally, you're going to have to work within that structure in those environments. But when you're talking out to the field, and for example, you're using mobile communications, and you're feeding that information to something, you can take that diagnostic data, for example, or even production data, and send it directly to a cloud where you're capturing the information and working with it. Again, that harkens back to the business drivers for the IoT. So in order to do that, you have to have the proper architecture to make sure that you're, for example, not draining batteries out in the field too fast, that it's secure, and how you actually establish those communications. So the foundation has also created, or is in the process of creating, additional extensions to the standard, which allow the devices, let's say, to talk either directly into the cloud in a secure way, using technologies that some of the large IT vendors use. So, for example, Microsoft, their cloud solution, which is called Azure, it uses AMQP. That's one of their native ways of communicating, and OPC is building that directly in. So you could use OPC directly from a device and talk straight into the cloud using AMQP. Another one that's coming is MQTT, and don't worry about the terminology. They're basically just message queues. It's how you communicate over the internet, let's say, in a secure way, and that's scalable and, let's say, protects the server from getting hammered by a lot of clients trying to connect to it. So whether you're talking to the cloud or you're talking locally, you want high-speed communications and you want to communicate between systems, but you need high-speed communications. There's also multicasting. Basically, the difference here being you either use client and servers to do sort of handshake and exchanges, so the clients ask for information and the servers provide it and back and forth they go, or you have a server that basically just broadcasts its information and whoever wants to pick it up does so, but therefore there's less back and forth between them and they can just stream the data faster, right? So there are different requirements, and the beauty of the OPC UA specification is that you're not limited to just one way of sharing that data, and it continues to expand. So as we watch the evolution of the IIoT continue, the standard is actually designed to allow different layers of it to be swapped in and out, and therefore whatever you've created will continues to be valid when you're supporting OPC UA, but over time you have additional options that get added to the specification. All right, and just to give you an idea, Microsoft very strongly bought into this. Windows 10 for the industrial side has embraced basically OPC UA as the industrial standard that Microsoft considers to be the one that they want to use when they're feeding data up into the cloud. They have created some already some bridges and let's say the listeners in the cloud. So basically for taking AMQP data. So from the shop floor, you're taking OPC UA, you're putting it onto an AMQP stream, which is just another, like I said, protocol primarily used to talk to the cloud, which then gets it into the, let's say, the Azure cloud, and then you continue to work with that. Now, if we look at, what vendors, let's say, in the industrial side are doing, Honeywell also, for example, its own cloud solution, which is built on top of Azure, also uses that. So again, by using OPC UA, you're also then, you have a way to convert, or you have a path to go from UA to AMQP to the cloud, and then you can start taking advantage of some of the analytics and things that are being built in the cloud. As I was showing in that diagram where, data goes up, you have to do a bunch of processing, you have to organize the information, and then once you take the results, then you start to see the benefits of, actually doing that analysis and acting on it. So anyways, point is, the large vendors, and there's a lot of them, whether it's the Oracles, the SAPs, and other automation vendors, they're all working towards this direction of being able to do some of the work on the data on premises, but also in the cloud. So OPC UA really helps to facilitate that. So okay, that's those are sort of the great, fun, big pictures up high. But now we also get down to sort of okay, so what do we do today? Now, some of the challenge, of course, that people see is that, well, they have existing infrastructure. So they have legacy systems, and they need to preserve as long as possible the return on investment on those. They see technologies changing very quickly all around them. So the question is, when do you sort of step into that stream? There's a lot of vertical silos, so there's uncertainty on how to tie them together. You know, the list goes on. Cybersecurity is also a huge one. People aren't sure how to protect their systems. So there's a lot of questions swirling around. So yes, there's kind of the carrot and the stick. The carrot is you can make a lot more money, and you're going to have to, well, I guess that might be the stick. To be competitive, you're going to have to shift somehow. But the question is how. Okay? So when we looking at that then, if we look at what we have typically in the plants, right? You're going to have your Purdue model, so you've got your, you know, your ISA 99 and 95 sort of laid out specifications for how you classify the assets and the layers in the network that you have, the components, and that's not going to go away anytime soon, right? Especially when you're talking about refineries or process industries. These systems are already in place. They're not just going to get torn out, and, you know, by a long shot, all the security hasn't been worked out. But there's definitely ways to put in various processes and equipment or systems that actually do enforce security, which dramatically improves, of course, the security of your overall system. So again, it's not just throwing technology at these things. You do have to obviously also have the policies in place and the procedures that have to be followed for security. But if we leave those to the side, and I leave that for the security and the IT guys to worry about, what I'm talking about is putting in systems which already support today and, let's say, are prepared for the future of secure communications, and how to deploy them and how to work with them as the company continues to work in its overall, let's say, security strategy. Okay, so you've got a middle tier. There's a lot of PCs that are being used for all sorts of things down at the lower tiers, whether it's facilitating communications between systems that are not compatible with each other, and therefore you have to go through a PC to do the translation and talk back down, or you're locally trying to capture that data, or you're trying to feed it through the DMZ up into the higher levels. There's a lot of complexity that currently exists because the systems today weren't designed with the idea of having sort of a collaborative working environment, right? They provide information based on the protocol. You can talk to them, but that was basically the extent of it for many of them. So today, if you're going to start using OPC UA, that actually brings in a differentiator for you as far as the ease of communications and sort of paving the way for the future as you start to take advantage of some of the higher connectivity that's provided by, you know, the IoT and the cloud concept and all the higher level type applications. Okay, so that's sort of where we are today. Now, if you're going to put OPC UA to work on the shop floor, there's a few sort of different scenarios that I guess we could say you're going to address. So on your shop floor, you're going to have different systems, and I'll just go through some of them here. And of course, the idea, as the arrows start to point up, because I'll be adding different systems in, the idea is that you want to eventually get to a point where everything is presenting an OPC UA face to the rest of the world, whether it's within the organization or out into the cloud. But basically, if we go on the premise that OPC UA has already been tested and proven to be a secure standard, or as secure as you can make it, you know, of course, nothing is 100% secure in the sense that you can't launch a denial of service attack against it or something. So there's always some vulnerability that's discovered and closed up, and you move on. But the point is, as far as today's best practices are concerned, OPC UA provides that security. So if you have the flexibility and the security, you want your systems to be able to do that, because they will then nicely plug in to the ongoing evolution of your enterprise, of your shop floor connectivity. So let's say you have a window PC and you have classic OPC on board. There's software that you can use that will allow you to translate directly from the classic OPC into OPC UA. So you still have the open connectivity. You're not removing or touching the system that's running as it is, but you can actually change that into the OPC UA stream. So again, you get the security, and you can also enrich the data. If you have systems that have proprietary protocols on board and you can't talk to them directly, there's software they can put into, for example, for us, we use like an industrial data logger, basically a hardened PC. It's locked down. It has all types of OPC servers on board, so it can talk to different types of protocols. It can talk down natively to the device, and again, you can feed OPC UA information out from it. Or you might have something that has an open native protocol, say like Modbus. So then what happens is you can actually use, a UA Modbus gateway, which is basically, and the graphic didn't work out here, but basically above it, it's supposed to be a small gateway, which allows you to communicate directly through OPC UA. It converts directly from the Modbus protocol up into OPC UA without even requiring a PC. Now, just take a step back. When we talk about custom devices, or what I call dark devices, so if you have a system that doesn't have diagnostics built on board, or it doesn't have the communications built into it, you can also add them on. Now, that usually requires a third-party, for example, product or something to be added in, which, for example, measures vibrations, for example, and you want to have high-speed communications that will actually capture that vibration data, so that eventually something can do the analysis on it and identify whether the ball bearings are getting worn out, or the lubricant needs to be replenished, or whatever the case is with the particular equipment. So that goes more into a POC, where now you're not just migrating, you're actually extending the use case. And then for those who are, let's say, vendors, if we have any vendors on the call, if you're trying to add OPC UA directly into the device, then you're basically more in an OEM type position, where you would use an SDK to actually bring the data, or you put the toolkit directly, you use it to put the communications directly into your device. So there are different scenarios on your shop floor or for your products that you might face, but basically in each instance, there's already something that you can literally get off the shelf in order to establish those communications, or to facilitate them. Okay, so if we look sort of towards tomorrow, then we're now moving, and we're sort of functionalizing things, or taking a more functional approach. So given that the security is going to be worked out, but it's no longer, let's say, such a huge issue as it used to be in the past, because OT enforces security as much as IT does as well now. So you're not getting a collision between them, because one can, trust the other to actually take care of the, let's say, network that it's using. You're basically getting your devices that are sitting on the shop floor, which are OPC UA enabled. You're probably going to be using IoT gateways of some sort in order to feed the data into the cloud, especially if you're retrofitting. But that now allows you, it starts to build that road upwards, so that you have that more free exchange of data up into the cloud, and you can start to consolidate information and, whatever, benchmark between different locations and such as you add additional devices into it. So just as a quick overview, when we did a POC in the past, again, we were dealing with a vendor, or end customer actually, oil company that was interested in doing a proof of concept on working, pumping data into the cloud. So when you're dealing with devices, we had a couple models. One was a device that had native communications that weren't open, so we used the OPC Classic server, shown in the bottom left box, where it was basically communicating via Classic OPC. It was converted into OPC UA, and therefore, again, exposing now a face of OPC UA upwards. And a Modbus device, and again, here the idea was to use, rather than going through a PC, to basically have that go through a simple gateway, which automatically converts Modbus traffic into OPC UA, which then was fed into what we call the IoT gateway. In this case, it was a data logger modified with just additional drivers to basically talk OPC UA one end, and then talk out over the protocol using AMQP. And then, of course, in the cloud, there was a component, the listener, set up to capture that data. And now you're starting to get information that's showing up in the cloud, and you're preserving the context of it. Now, the key thing is, when you're starting to use, again, these small appliances, you're starting to get the communications that you traditionally had to establish using a PC, and this is just a small box. You plug it in, you configure the IP address and identify what it's connecting to or what the profile is of the device below. And from that point forward, whoever connects to it from the above area, or when you feed the information up, you're now dealing with actual, rich tag-based data as opposed to just working with registers. So that was one way that we implemented that. Started the company on starting to talk into the cloud and start to work with sort of the more IoT type concepts. So in the future, this is just going to continue. The legacy systems that I show at the bottom, the conversions between proprietary and then classic or UA, that's going to, of course, continue because they're not going to disappear overnight. Other devices will talk UA directly, and they'll, for example, talk into the gateway or talk up directly into the cloud as shown on the right. And as well, on the shop floor, you're going to start to see devices talking OPC UA amongst each other, so sort of the M to M. Doesn't mean that what that does mean is you don't have to talk directly into the cloud. You can actually feed that data between the devices sort of on that on the shop floor. So again, OPC UA it's fortunate that OPC UA came out around the same time that we started to see, the whole cloud and IoT phenomenon take place. But really, OPC UA was already designed beforehand, years beforehand, for actually efficient communications on the shop floor as well as upwards. So it really sort of fits the bill for both sides, whether you're trying to push into the cloud or you're trying to improve communications and the cost of implementing those communications on the shop floor. OPC UA fits both profiles quite nicely. Okay, so when you're talking about starting these, whether you're doing migrations or POCs, the way I'd break it down is, number one, you do have to prepare the ground sort of works if you're really looking to the future for how easily you're going to sort of run things. So the migration or adoption story is on the data connectivity side. That's things that you can do today to start to basically improve how the connectivity and security is set up on your shop floor. And then when you're considering doing POCs, or you're looking at, okay, so how will we reduce that data set as we start to connect all these things together, either at the edge, so doing some of the fog computing, or when you're pushing it up into the cloud, that's supposed to be more of a POC, a proof of concept conversation with one or two vendors or whoever's partnering from a technology standpoint in order to deliver that. Okay, so really, guys, to conclude, when you're talking about OPC UA data and you're trying to extend the visibility, add additional, for example, diagnostics information, or you're trying to reach deeper down, you're going to need, a good way to go is to use the OPC UA connectivity, which will become more and more prominent anyways down the line. So it's a good investment today for the future. So basically, you would use those types of components, and I just list a few of them here, like proxy and wrappers, which are applications for allowing classic connectivity, OPC connectivity, to work with UA. Whether it's the Modbus gateways, which are the small devices which basically don't require a PC to do communications, data loggers, which have a lot of connectivity to various devices that talk natively and then feed information upwards, or even the SDK, that's more if you're implementing things on board your device. So to start sort of a phased adoption or migration towards OPC UA, this is the way to go because, again, you're not disrupting what you have on the shop floor now. You're just adding that capability and opening the doors to bringing in more OPC UA-enabled equipment. If you're looking for sort of doing IoT POCs, the proof of concepts, and the reason we do POCs or proof of concepts is rather than going whole hog and just starting to convert everything and then figuring out, what works or doesn't, or how specifically you want to adapt your culture in your company to sort of this digital transformation, by identifying key, let's say, preliminary business drivers and actually working with what you have and extending that, that is let's say, the safer way to go, right? So on this side, there would be more of a consulting angle where maybe some custom development is done, which is typically quite small, and it's basically developing some of these smaller, like I said, diagnostic sensors or whichever to sort of bring that into, bring those parts of the plant that aren't, for example, visible right now, or that type of equipment, starting to collect that information, figuring out what to do with it. That side of things, that's what the POCs are excellent for, to start showing some, let's say, early wins for what that technology provides for you. Because in the end, it has to have some kind of, it has to move the needle on the business side to, let's say, get buy-in from leadership to actually, move more of the system that way. Okay, so as next steps, really, there are three things that I'd point to. If you are interested in working with the OPC UA or starting to do some of the adoption or migration, I'd encourage you, if you want to inquire about it, just write to us at customer care at matrikonopc.com. That's where you will, someone will get back to you, of course, and we'll look at, what you're trying to do and help you out. If you're looking for doing some kind of proof of concept, so you're actually saying, okay, we would like to start identifying the business drivers and seeing how we could bring that technology together, whether it's just the connectivity from Matrikon or tying into what Honeywell can offer or other technology partners, write to me. And if you're looking you're on the vendor side of the equation and you're actually thinking, how can you enable your products to actually offer the UA connectivity, which of course will be demanded in the future, I'd recommend that you write to Jason Fletcher. He's our sales manager, and he will work accordingly with you as well. So this will be all made available to you afterwards, but just to put a bug in your ear, if you are looking to do these types of activities, we are more than happy to work with you on them. Okay, I was going to have some questions, but I see that unfortunately our time has run short. There's always so much to talk about with these on this topic. So if you guys have anything, you saw my email there, feel free to write to me. I'll be more than happy to answer your questions or to have more conversation about it. And yeah, so that's it for my presentation. So thank you very much, and I look forward to speaking to some of you or to working with you in the future. So hope you found it useful. Thanks a lot and have a great day.